Okay, I thought I would do some of each type here because I know that some people just have a hard time remembering things about slope. So this is the oral exercises, and we're going to look at how we would count off slope off of a graph in case you've forgotten how to do it. So we're going to start with, we're going to do the ones I assigned, 1 and then 3 through 5. And we're just going to quickly try to do all those. And I'll do it, I'll write in green so that maybe it'll pop out at you. So if you look at number 1, you're trying to find 2 points to count from that fall right where two of these horizontal and vertical lines meet. So like 0, 0 is a great point to pick, right? So you're looking for another one so that you can count to it. The first one I see that I can tell really ends on a hash mark is like up here. I'm going to put a dot right there. So if I want to count that, I'm going to rise to, remember slope is rise over run. And if we go up, that's positive, okay? So I'm going to rise up 2, so it's a positive 2 on the slope for number 1. And that puts me here, but then I got to run over to the left 1, 2, 3, 4. So it's negative 4 because I went left 4. Okay, so you go left, it's negative, right, it's positive. And when you're counting the rise, up is positive, down is negative, okay? So that would be negative 2/4, but we would want to reduce it to negative 1/2. Now if you look at, I'm going to go ahead and do number 2. If you were trying to do that, you could pick 2 points right there. You would rise 0 and run 1 if you pick 2 points, but 0 over 1 is 0. And what we really want to know is that a horizontal line has a slope of 0. We really don't want to have to count that off every time, but we could, and that's just what I want to just make a point there. All right, number 3. Here we'll pick this point right here because it's a good one, and it looks like there's another good one right there that's easy to count to. So we would rise up 1, so that would be a positive 1, and then we would run over 1, 2, 3, so it'd be a positive 3. Now number 4, because I did assign 3 through 5, I did 2 as an extra. On number 4, if you're looking for a good point, looks like there's one on the y-axis. As a matter of fact, this one has a y-intercept of 3 because that would be 3 units up right there. And if I'm trying to find another good point, I'm going to pick this one right here. There may be one up, but I'm just going to pick this one right here. Now, I could start counting my slope from any points. So I don't have to start at the y-intercept. I could start down here at the low point and I'm going to go up 2. Well, up 2 means positive 2. That's the rise like an elevator on the top. And I'm going to run over 1 to the right, so that'd be a positive 1, so 2 over 1 is 2. Now, if you're looking at number 5, we can tell there's a good point right there, so I'll pick it. And looking for another good one. It looks like it's going to hit right here, and they kind of did that on purpose, I think, to mess with us. Another one I could have picked was up here, okay? I'm going to start at the one on the x-axis, and I'm going to count to the one lower, okay? So I'm going to go down 1, 2, let's see, 1, 2, 3, 4. So that's minus 4 because I went down 4. I went down 4 like this. And then I'm going to go to the right one, so that's a positive 1 on the bottom. And negative 4 over 1 is negative 4. Okay, we will have done 20 and 22 in class, but I'm going to go ahead and do 19 and 21, the ones I assigned in case you're still struggling. Okay. Now, one thing that's good about 19 is they count straight in a row. 1, 2, 3, 4. If you remember from a table, I can find the slope by saying, well, what is slope? You know, yeah, it is rise over run. But another way we can think about slope is to say that slope, and this is the thing about slope, there's so many ways to think about it. It's how steep something is. But from a table, we can say it's the changes in the y's on top, because remember on the slope formula we subtract y's on top. And that little triangle means just how much did they change. And we usually find that by subtracting. And then on the bottom it's change in x. Remember the slope formula was actually y2 minus y1, so we subtracted the x's on top, we subtracted the y's on bottom. Well, I could subtract, or I could just say how much do they change, okay? So from 1 to 2, that's just a plus 1. From 2 to 3 is a plus 1. 3 to 4 is a plus 1. All of these, in other words, ended up being plus 1. Well, that's my change in x on the bottom, so let me just put a 1 there. Now let's look up here. How much did your y's change? This goes on top. I'll do this in green just to make a difference here. So from 9 to 7, that's a minus 2. From 7 to 5, that's a minus 2. And from 5 to 3, that's a minus 2. They were all the same, weren't they? So I know my change in y is always minus 2, and minus 2 over 1 is negative 2. Let me write it down here. Now, 21, they're messing with you a little bit. Actually, they're not. But they don't, if you think about the slope over here, for 21, it is the change in y over change in x. Now, there's two ways I can do this. And the reason I'm going to, I just want to make a comment about this. They are, if you go on your x's and you're looking how much they change, that goes up plus 5, okay? That goes up plus 5. And this goes up plus 5. They didn't have to make them all equally distant. It's easier for you when they do. Here I can see that the change in x is always 5. So if the change in y's better be the same since the changes in x were the same. I just want to make a comment about this. A lot of times on standardized tests, and I could see them doing this to you on the SAT, okay? They will not go the same number of x's, and that doesn't mean that that's not a line. It's not a function. That we know this one over here that we first did, that was a function, and it actually is a line because the changes in the y's and the changes in the x were always the same. And the same thing is going to happen over here. But they could have skipped, like x is negative 4 and maybe y is 2 and then y is 6 and maybe y is 7. And in that case, I'd have to use the slope formula between each 2 points to see if they were on the same line. And luckily, that's not what they did to us in this book, but I just want you to be aware that that can happen. Let's look at our change in y's here. From 2 to 4, oops, I wanted to do that in green just to be consistent. That's a plus 2, that's a plus 2, that's a plus 2. So it's a plus 2 or a positive 2 on top, and 2, that would mean our slope was 2/5 there.